Hey, what is up mga bubuyog? At huling halimbawa na po tayo sa ating design for Flexure and Shear. Let's go! Alright, so yan, tignan natin yung ating problem mga bis. Sabi dito, the channel section carries a uniformly distributed load. Ito, yan. UDL yan na yung total is 6W. Again, total yan, hindi yan yung intensity, okay? And 2 concentrated loads of magnitude W. Yun, sa bawat dulo. So, overhanging siya. Now, ito yung questions natin. At A, verify that the neutral axis is located at D is equal to 50 mm. So, ito daw, ang neutral axis daw natin is located 50 mm from the bottom. Yun. And that the moment of inertia about that axis is 15.96 times 10 raised to 6 mm raised to 4. So, given na rin yung ating I or the centroidal moment of inertia. Okay, so kung given, okay, i-verify daw pala natin. So, isosolve ulit natin para i-prove lang natin na tama yung sinasabi niya that D is 50 and the value of I is that. Okay, so gawin natin yan mamaya. And letter B, determine the maximum allowable value of W. So, andito yung mga working stresses. 40 MPa, naka-specific na siya. Tignan nyo, in tension and in compression and 24 MPa in shear. So now, kung makikita natin mga bis, our section is unsymmetrical. Unlike our first three examples which are symmetrical in nature. So kapag unsymmetrical siya, is alam natin na sa bending or flexural stress, kailangan nating mag-solve ng apat or either dalawa or apat na values ng ating bending stress to conclude which one of them will be the maximum. Okay? Kasi 'di ba, ang formula natin for flexural stress or bending is that is MC over I, right? And itong ating M mga bis, kailangan na natin i-consider yung maximum positive and maximum negative. Kasi unsymmetrical na yung section natin. Okay? So, kailangan natin i-consider yung dalawa. Unlike kapag symmetrical yan, yung absolute maximum yung kinukuha natin. Now, dalawa yung values ng M natin. And then next, itong ating C, magiging dalawa din yung values niya. Kasi 'di ba, hindi na siya symmetrical. And kapag hindi na symmetrical yung ating section, the distance here is not equal to the distance dito. So, C is not equal to C. Magkaiba yung dalawang C na yan. Therefore, we will also have two values of C. So, we will have two answers in maximum positive, two answers in maximum negative. One is in tension, one is in compression. So, bali apat lahat yan. Okay? So, kailangan nating isolve yung apat na yon para makita na lahat ng possibilities. Okay? And then, lastly, consider din natin yung ating shear. So, bale, yung end goal natin dito is produce 5 answers and we will compare all those 5 answers to check which one will be our final answer or the safest value. Okay, so simulan natin sa A. I-verify daw natin yung location ng kanyang neutral axis, ito, which is 50 mm above the bottom, and then itong value ng centroidal moment of inertia. Okay, so simulan natin sa neutral axis. Para gawin yan, gamitin natin yung formula na bar y is equal to summation of ay over summation of a. Okay, so this bar y is also equal dito sa d. Okay, so gawin natin reference point yung pinakababa na to. Okay, so this d is also equal to bar y. Okay, so summation of ay, that's area times y. So yung gagawin ko mga bis, hahatiin ko itong ating beams into 3 parts. 1, ito. Tapos, pangalawa to. So, parehas lang sila. And then, pangatlo itong nakahiga. So, para gawin yan, simulan natin dito. That would be 2, right? Kasi dalawa sila. 2 times, ano yung area nito? That's same as 140 times 20. 140 times 20. Okay, so, ano yung y? Y is the distance mula sa centroid ng figure natin. Ito, ng figure na to. Papunta sa ating temporary reference point. And that is equal to 140 divided by 2. It's 70, di ba? So, 70 yan. So, tinamultiply ko na sa 2 kaya na-cover na yung dalawang to. Okay? And then next, itong nakahiga naman na to. Ang area niyan would be equal to 140 times 20. 140 times 20. Ano yung value ng y? That is the distance mula sa centroid nito papunta sa ating temporary reference point sa pinaka-bottom. That's equal to 20. Di ba kasi 20 to divided by 2 magiging 10 na lang. Okay? I-divide natin yan sa summation ng areas. So, that's areas nito ay 2 times 140 times 20. Yun yung area ng dalawang to. Plus, yung area na nakahiga, that's 140 times 20. Okay, so solve na lang natin yan. Makukuha natin yung bar y or this value d. Okay, so our final answer mga bis is 50 millimeter. So, ayun. Na-verify natin yung location ng neutral axis. Tama. D is equal to 50 mm. Okay, so tama. Next, isunod naman natin itong I or the centroidal moment of inertia. So, kung makikita nyo mga bis, no, unsymmetrical yung ating section. So, gagamit tayo ng parallel axis theorem. Okay, so using parallel axis theorem, same yung gagawin yung technique. Yung dalawang figure na to, tapos yung nakahiga. Okay, so dalawang I ng vertical, IV, yan, naka-vertical na parts, tapos plus yung centroidal moment of inertia ng nakahiga. Okay, I horizontal. Okay, so dito sa ating mga vertical parts, simulan natin. That will be 2. Kung makikita natin, these are rectangles, right? So that would be base times height cube over 12. And since we are using transfer distance method nga, we will add here the area times y squared. So, ano itong y mga bis? That y is the location from the centroid of that figure papunta sa ating neutral axis. Okay? So, tingnan natin yan mamaya. So, next, sunod din, same plus. Yung horizontal naman natin, same din. Since rectangular yung nakahiga na to, that is base times height cube over 12 plus ay squared din. Kasi nga transfer distance. Okay? So, now, let's just input the values. So, we have our base. Our base dito sa ating vertical, di ba? Sa vertical parts na to is, that's 20 mm. Times the height. What's this whole height? That's 140. Cube divided by 12. Plus, dito naman tayo sa ay squared niya. What is the area of this figure? That's 20 times 140. 20 times 140. Okay, next is this y squared. Ano itong y? Y is the distance from the centroid of this figure punta sa ating neutral axis. That length, okay? So, paano natin makukuha yan? Kung makikita natin mga bis, di ba? Mula sa bottom, pupunta sa centroid, this is the half of 140, which is 70. And alam natin that this height is 50 mula baba hanggang neutral axis. So, isubtract na lang natin. 70 minus 50, we know that this is 20 millimeters in distance. Okay, so this is 20 squared. Okay, so close parenthesis plus. Okay, so dito naman tayo sa nakahiga. Ano yung base nito? Ang base niya is 140. Okay, so that's 140 times the height. The height is 20. Ito. So that's 20 cube divided by 12 plus. Ano yung area nito? Same din, 140 times 20. So, ilagay ko lang sa baba kasi kulang ng space. Times, ano itong y? Y is the distance mula sa centroid nito papunta sa ating neutral axis. And this is equal to 40 millimeters. Bakit? Kasi yung buong ito ay 50, right? And I know that from the bottom, papunta sa neutral is 10. So, 10 plus 40 is 50. So, this distance is 40. Okay, so times 40, don't forget, naka-square yan. So now, calculate lang natin yan. Kapag tama yung sagot natin, it should be 15.96. Okay, so tignan natin. Okay, so our answer mga B's is equal sa 15.96 at 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3. Kapag gagawin natin yung exponential form, that would be also equal to 15.96 times 10 raised to 6 millimeter raised to 4. Okay, so check din. Tama. Na-verify na natin yung location ng neutral axis which is andito and the value of I which is 15.96 times 10 raised to 6. Okay, so okay na tayo sa letter A. Na-verify na natin sila. Okay? So i-erase ko na to. Hindi na natin to kailangan mga B's. Now, proceed na tayo dito sa letter B. We will now solve for this W. Okay? So at bending, magkakaroon tayo ng 4 na sagot ng W. Diba? Na-discuss natin yun. Bakit kanina? And sa shearing, magkakaroon tayo ng isang sagot sa W. So, solve na natin yan. Tignan natin. Ang formula para sa ating bending, either compression or tension, it will be just the same, will be equal to MC over I. And for our shearing, that is VQ over IB. Okay, so i-analyze natin yung mga given. So, we need to solve first this M and V. This M is the maximum moment both positive and negative. Kailangan natin i-consider both kasi yan symmetrical. And then this V is the maximum shear. So how will we solve for this maximum positive moment and maximum negative moment? So how will we solve for those? We'll sketch the shear and moment diagram of this beam. Okay, so sketch natin yan. Andito, ginawa ko na pala. So ginawa ko na siya para makabawas tayo ng oras sa pagsusolve. So konting rundown lang. Ano yung mga total ng downward forces? This is 6W yung total nito, di ba? So 6 plus 1 plus 1, so 8W lahat to. And since symmetrical silang lahat, hinati ko na sa dalawang reaction. So 4W, 4W. Okay, so pwede yun. Or kung gusto nyo rin, you can use equilibrium equations to make sure. Pero kasi, nakita ko na parang ano siya, parang symmetrical. O symmetrical talaga yung positioning ng mga loads. So, nahati sila equally into 2. So, this RA and RB is the same as 4W. Okay, so sunod na tayo. Simulan natin yung ating shear diagram. Itong ating shear diagram, this, sa dulo, meron tayong W going down, so negative W. Tapos, tantananan, constant. Pagpunta sa A, may reaction A, which is 4W. So, umakyat tayo. Negative W plus 4W is 3W. And then, yung total kasi nito is 6W, right? So, 3 minus 6. Kaya, naging negative 3. So, pagpunta dito, pag-akyat, meron tayo ulit ditong reaction kasi, which is 4W. So, bumalik siya sa positive W. Then, balik dito. Sa dulo, may W yung pababa. So, balik sa 0. Okay, next. Okay, sa ating moment diagram, dito pala, meron tayo ditong point of 0 shear. And alam ko na ang location yan is 2 meters from this point and also 2 meters from this point. Bakit? Kasi symmetrical sila, di ba? 3W or 3W. So, you can check that via ratio and proportion. Now, to continuing with our problem, dito, this is a negative area. So, ang area nito is W times 1 is W pero negative nga. So, bababa siya. And then, dito mga this triangle is a positive area. So, 3 times 2 divided by 2 is still 3. So, from negative W, I will add 3W. So, magiging 2W na lang. And since dito symmetrical sila, same area, babalik lang ulit sa negative W. Then, ito, positive area, same lang din doon. Bumalik siya sa 0. Okay, so this is our shear and moment diagram. Now, ano yung kailangan natin? Dito sa ating shear diagram, we need our Vmax, right? And our Vmax is the absolute maximum shear. And that is equal to 3W. Dito sa ating moment, kailangan natin yung Mmax na positive tsaka yung maximum moment na negative. Yung ating maximum moment na positive is 2W. Okay, yung ating maximum moment na negative is negative W. Okay, so W na lang. Parehas din naman. So ngayon mga bisno, ang itsura ng bending ng beam natin dito would be the invert of our diagram. So pag ganun siya. And ito naman pag ganun. So important yan para mas madali nating ma-visualize nasaan ba yung tension and nasaan ba yung compression sa taas ba or sa baba. So, at maximum positive, andito, pag ganun siya. And at dito sa baba, pag ganun siya. Okay, so malalaman natin na sa taas yung compression, sa baba yung tension. Dito, sa taas yung tension, sa baba yung compression. Okay, so, copy ko lang ito. Ayan. And balik tayo sa ating main problem. Okay, so nasolve na natin itong ating M and itong ating V. Next, itong I mga bis, okay na rin yan, di ba? Na-solve na natin yan kanina. Dito sa ating bending stress, mga bisno, the value of our C, malalaman natin yan mamaya. Depending kapag compression yan or tension. So, dalawa kasi yung value ng C. Dito, tsaka andito. So, depende yan kung anong isosolve natin, tension or compression. So, okay na rin to. Okay na tayo sa bending stress. Okay, so dito naman tayo sa shearing, mga bis. Saan ba yung location ng maximum shear stress? Diba? If I'm not mistaken, it is also located here sa ating neutral axis. Bakit, kamo? Kasi, alam ko, in theory that we said that Q is maximum at neutral axis and B should be minimum. And kung makikita natin, yung ating B ay minimum also sa neutral axis. Therefore, I can conclude that our maximum shearing stress occurs at the neutral axis because it produced the highest ratio of Q over B, which are only the varying factors. So yung kailangan kong Q dito, this variable Q is the Q at the neutral axis. And I need to solve first for that para diretso na lang yung substitution natin mamaya. Okay? So what is the Q at the neutral axis? Okay, so pwede tayong pumili kung ano yung i-solve ba natin, yung sa taas ba or sa baba. Pero ako, I will choose yung sa above this neutral axis kasi mas madali lang. Dalawang figure lang eh. Okay, so the first moment area of the neutral axis is equal to 2 kasi dalawa yan para mas madali. Tapos, multiply natin yung area ng figure na to. Yung area niyan would be equal to, ano ba yung distance na to? This distance is equal to 140 minus this D which is 50. So, 140 minus 50 is equal to 90. Okay, so this is 90 times 20. Yun yung area niya. Tapos, kailangan nating i-multiply yung location, yung distance from the center of this figure towards the neutral axis. And that is equal to 90 divided by 2, which is 45. Okay, so our Q at the neutral axis is equal to, that's 162,000 millimeter raised to 4. Okay, so Q and A is equal to 162,000 millimeter raised to 4. Okay, so ngayon, ready na lahat mga bis, di ba? Nakuha ko na lahat ng ang mga kailangan ko. MCI, itong VQI, tsaka B. Okay, so simulan na natin mag-solve. So simulan natin dito sa bending stress at bending or flexural. So at, di ba sabi natin na magkakaroon tayo ng 4 na sagot dito. 2 sagot sa positive moment and 2 din sa negative moment. 1 is in tension and 1 is in compression. Okay, so unahin natin dito sa positive moment. Positive moment, which has a value of 2W and ganito yung pag-bend niya. Sa taas yung compression, sa baba yung tension. Okay, so we start here at the top or the compressive stress. So, compressive stress or bending stress is equal yan sa MC over I. So, let's just substitute our values. Our working stress for compression is 80 MPa. And we know that megapascal is also equal to Newton per millimeter squared, right? So, yun yung gagamitin ko para mag-cancel sila ng units dito. So, 80 Newton per millimeter squared is equal yan mga bis sa, what's our M? Yun ulit, 2W. What's the value of our C? The value of our C is the distance mula sa neutral axis papunta sa top. Bakit sa top? Kasi alam natin na sa top yung location ng compression. Eh, di ba compression kasi yung sinosolve natin for now? Sa baba yung tension. So, our C for now is this length. Okay? So, that length is equal to 140 minus 50 which is equal to 90. Okay? That will be equal to 90. Okay? So, 90 millimeter divided by the value of our I. Ayan. Na-solve natin kanina yan. That's 15.96 times 10 raised to 6 millimeter raised to 4. Okay, so before tayo mag-shift solve mga bisno, remember that this 2W has a unit of meters, right? Kasi 2W is a moment, di ba? And sa ating moment, shear and moment diagram dito, ang ginamit nating unit of length is in meters. So, kailangan muna natin i-convert itong meter into millimeter para pareha sila. So, let's just assume na may meter dyan. And let's use the conversion ratio that 1,000 millimeters equal to 1 meter. So, cancel M, cancel M. Therefore, we can now solve for the value of our W. So, W will be now equal to 7,093 newtons. Okay? So, our answer is in the unit of Newton kasi yun lang naman yung natira. Lahat na ng millimeter na to, nag-cancel na sila. Okay, so ito yung una nating sagot. Now, let's proceed naman sa tensile stress. Diba? Kasi this is in compression. Consider din natin yung tension sa baba. And same formula, that's MC over I. What's the value of our tensile stress? The working tensile stress is 40 MPa. Yun yung sa tension. Okay, so 40 yun. 40 Newton per millimeter squared is equal to, what's the value of our M? It's the same. We are still working on the positive moment times C. Ngayon, yung value ng ating C is this one. Okay? Ito na yung C na kailangan natin. Kasi sa baba yung tension. Kasi ganun yung bending niya eh. Sa baba sila naghihilan. So may tensile stress dyan. So that's 50. Okay? So the value of our C is 50, and don't forget to multiply our conversion ratio sa taas, parehas yun lang, divided by I. What's our I? Same then, 15.96 times 10 raised to 6. So with that, we can solve again for the value of our W. So it's equal to 6384 newtons. Okay, so na-solve na natin yung dalawang value ng W natin with respect to positive moment. Now, punta naman tayo sa ating negative moment, which is equal to W. Okay, and yung pag-bend yan is paganyan. Sa taas yung tension naman, sa baba naman yung compression. So, simulan din natin sa compressive stress. So, at compressive stress, same formula, MC over I. What's the value of compressive stress? That's 80 Newton per millimeter squared. The value of our M ngayon is just W. Okay? And the value of our C is this 50. Bakit yung 50 ngayon? Kasi dito sa negative moment, no, ang location ng compression is sa baba na, andito. So, from neutral axis papuntang baba, that would be 50. Okay? And don't forget to multiply our conversion ratio, which is 1,000. So, ayun, di ko na nilalagay yung units para hindi humaba to, no? So, 15.96 times 10 raised to 6. Napakita naman natin dito yung cancellation. So, same. Shift solve natin yan. 25,536 Newton. So, ayan, medyo malaki. Tapos, punta din tayo sa tensile stress. Tensile stress, same formula, MC over I. Okay, so value ng ating working tensile stress is the same as 40 Newton per millimeter squared is equal to moment. Ang moment natin ngayon ay W lang. Times the value of C. Ang value ng C natin ngayon, makikita natin, would be equal to 90. Sa taas na siya, di ba? Sa taas yung tension. So, that is 90 millimeters. 90, and we don't forget to multiply yung ating ratio, which is conversion ratio 1,000. Divided by the centroidal moment of inertia, 15.96 times 10 raised to 6 millimeter raised to 4. So, shift solve ulit natin to solve for W. Our answer, mga Bs, is also 1793 newtons. Okay? So, ayan. Ito yung apat na values ng W with respect to bending. So, hindi pa tayo makaka-conclude for now. Punta muna tayo sa shear. I-solve muna natin itong natitirang shear before we can conclude. Okay? So, punta na tayo dito. At shear. At shear, iisa lang yung value na kailangan natin kasi alam naman natin yung location ng maximum eh. So, at shearing, that is tau is equal to VQ over IB. What is the value of this tau? This is the working shearing stress. That's 24 MPa. 24 MPa, or I should write Newton per millimeter squared is equal to V. What's the value of our V? Saan ulit yon? Yon, Vmax is 3W. And the value of our Q, na-solve natin yan, that's 162,000 millimeter raised to 4 divided by I. Our I is yon, 15.96 times 10 raised to 6. And next, multiplied to B. B, mga Bs, is the width of the cross-section. And yung cut section natin is andito, di ba? So, this length only. Ito, tsaka ito. So, that's 20 mm plus 20 mm is equal to 40 mm. So, times 40. Okay? So, dito mga Bs, hindi ako mag-multiply ng conversion ratio, which is 1,000. Kasi yung V natin is a force. So, there's no length. Unlike M, which is a moment. Diba yung moment, yung unit kasi ng moment is force times length. So, since my length, may meter doon. Dito, V lang yan, which is a force. So, no meter. Okay? Shift solve na lang natin yan. Okay, so yung sagot natin mga Bs ay napakalaki. 31,526 newtons. Okay. So, ngayon mga Bs, mag-focus na lang tayo dito sa 5 value na to. Ito, tsaka ito. Okay, so tingnan ulit natin yung tanong. Ano yung maximum allowable value ng W? So, these are the 5 choices for W. So, ano yung pipiliin mo? Kahit hindi ka pinili. Char. So, ano yung pipiliin natin mga Bs? Pipiliin natin yung pinakamababa, of course, di ba? So, from this 5, this is the lowest, which is 6384 newtons. Ito yung pinaka-safe na maximum value ng ating W. Okay? Okay, so kunwari mga bis, no, ito yung pinili natin. Kasi sa buhay naman, hindi naman lahat ng choices natin ay tama. Minsan, yung pinipili natin is yung maling tao, di ba? Char. Okay, so yun. Kunwari ito yung pinili natin. Kapag ito yung pinili natin mga bis, may pag-asa ka pang safe ka for shearing. Okay? So, hindi pa siya mag-fail due to shearing. Pero sa tingin mo ba, hindi siya pero sa tingin mo ba, dito mga bis, at bending, safe pa rin ba siya at bending? Dito, for example, sa ating compressive stress. Dito sa ating compressive stress, mag-fail siya. Kasi yung ginamit mo ay 31, yung kaya niya lang ay 25. So, kapag pinilit mo sa capacity niya, bibigay siya. Okay? Pero kapag ito yung ginamit natin, kapag tama yung choice natin, let's say ito, ano yung mangyayari? Safe siya dito sa bending stress. Okay? So, hindi siya mag-fail dito due to compression. Kasi yung capacity niya 7093, pero lesser than that yung binigay mong load. Lesser than that yung binigay mo dito. Same with that and same with that. So, safe siya sa lahat ng possible scenarios. That is why we are considering everything that might happen. So, compression, tension, and the shearing. Okay? So, I hope nakatulong itong ating video kahit napakahaba. So, maraming salamat kung nagstay ka dito hanggang sa dulo. If you have some questions or clarifications, comment it down below at susubukan natin yung sagutan. So, ayan, please like, share, and subscribe. Muli, ako po yung bubuyog na nagpapalala sa inyong maglakbay, mag-enjoy, mag-grow, maliksik, maging matinik. Jabi out.